All right, so yesterday we looked at how to draw dot diagrams for ionic compounds. Remember, if you're a positive ion, if you lose electrons, you are said to be
Positive.
naked. No electrons. You don't put any dots around it. If you're a negative ion, you are completely full of electrons. So, those are ionic compounds. That's metal, non-metal. What do we do if we have a covalent molecule? Okay, non-metal, non-metal. Here we go. Add up the total number of outer shell electrons represented by the elements in the compound. So find them on the periodic table, determine how many outer shell electrons you have. Record that number. That's how many electrons you will have to deal with. Start with the elements you have the least of, and place it in the middle. Never choose hydrogens. Those of you who played with Tinker Toys, you're going to know exactly what I mean, because there were some pieces that you never started with because they were stuff you added at the end. Yeah. Hydrogen is like those little flags or the little dooflachies that you added only once your design was done. Hydrogen is an afterthought. Place elements around it as symmetrically as possible, making sure that everyone has at least partial control of 8 electrons, except for hydrogen, because the noble gas that hydrogen wants to be like is helium, and helium only has 2 electrons. 2 electrons. All right, here we go. I'll do the first one for you, talking myself through it, and then we'll have different volunteers do them from now on. Okay, so what you do first is look at carbon on the periodic table. It's in the 4th column, so that gives you 4 outer shell electrons to play with. Then you look up hydrogen. Hydrogen is in the 1st column, and there is 4 of them. So I use my calculator. 4 plus 1 times 4 is
4.
8.
Oh.
That's why it's important to use your calculator if you need to.
What did you say?
So you have 8 electrons in the outer shell that you can play around with. Now you need to find the monkey in the middle. Did you ever play monkey in the middle when you were a kid?
No.
Okay, so for those of you who did not, you would be in the middle and people would throw a football or some kind of ball.
Oh, yeah.
And if you caught it, then whoever threw the football was now the monkey in the middle. And if you didn't, then if you had some really good athletes that you were playing against and you were a little nerdy, like a guy I knew, then you would spend a long time being in the middle. Carbon is the ultimate monkey. Why? For reasons that I will eventually explain to you, carbon's dot diagram is actually like this, not like this, as we would predict. That means that carbon has the ability to bond 4 times. If you're playing Tinker Toys, this is a great place to start because you have the most attachment points. So carbon's in the middle. Then you place the 4 hydrogens around it as symmetrically as possible. That's an easy one. You got 4 sides, north, south, east, west. You got 4 hydrogens. And then you place the 8 electrons so that in order to connect 2 atoms, you have them each share, at least partially, an electron. So 2 electrons between 2 atoms allows those atoms to stick together, to be bonded, to be covalently bonded. Now, it can be kind of old putting dots down, so there is a shortcut version, and that's simply connecting. The dots give you a dash. So a dash represents 2 electrons. If you see a dash, that's 2 electrons. A dash is 2 electrons. And that is the dot diagram for methane. You should always check before you leave it. Does carbon have at least partial control of 8? 2, 4, 6, 8. Yes. So put a little smiley face right there. You don't have to put smiley faces. Okay. Do each of the 4 hydrogens have control of at least of just 2 electrons? 2, 2, 2, 2. Yes. They are all happy. It's Compassion Week, so let's draw little smiley faces everywhere. It's nice to be kind sometimes.
Except for when you walk in really early and they're like, hi, pencil, and you're like, oh my god.
Or they're like,
All right, here we go.
You got it?
Who wants to volunteer to start us up? All right, Jackson.
Jackson was
Then
all about it.
volunteer Devon next. He wants to go next. All right, nitrogen. How many? Which column is it in?
It is in the
5th column.
How?
You don't count the middle 10.
Oh, yeah. Okay.
Fluorine. Jackson.
7 column.
Times.
4, 1, 4, 3.
Oh, I read its number. I said
Oh, wait,
7.
okay, I got you. You got times it by that. Wait, so how's it in 4?
So 7 times 3 is plus 5. All right, you have 26 electrons to play with. 26. Who's the monkey in the middle? Usually the one you only have one of, or carbon. Carbon's the ultimate monkey. Nitrogen. All right? Are you going to be a left, right, top kind of guy, or do you want to go on the bottom?
Go on the bottom.
All right. We connect the atoms using a dash, and a dash represents how many electrons, Jackson? So 2, 4, 6. Okay, here's a very important rule. When you start placing the other electrons in the form of dots, you have to go from the outside in. Outside in. So make sure you dot up the middle one last. All right, Jackson, you've placed 6. Let's go. Say 8. Good.
Oh, I get it.
Say 10. Good. Do you see the pattern?
12.
What comes after? All right, 12.
Okay, I got you. And then 14, 16, 18, 20, 22, 24.
And above it, oh, that's cute.
Have we placed all our electrons?
No.
You counted to 26, and 26 is what we needed to go.
2, 4, 6, 8, 9, 10, 11, 12.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. The lines are 2. That's why we started counting at 8. All right. Is everyone happy with 8, Jackson? 2, 4, 6, 8.
Yes.
2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8.
That's a lot of that. Everybody's happy.
Then that is the dot diagram for NF3. H2O. Go, Devon. Times. And oxygen? 1 times 2 is? Plus 6? Who's in the middle? So how many electrons have we now placed? Do we place them around here? No, hydrogens are done. When hydrogen bonds, it's done. When hydrogen wants to be like the noble gas helium, helium only has 2. So, hydrogen is now like helium right now. It's done. It's happy. No, no more dots. It's done. Hydrogen is afterthoughts. Hydrogens, did you ever play with Tinker Toys when you were a kid? No? Okay, there were like pieces that you put in at the end in order to make it pretty. Hydrogen is a piece you put at the end to make it pretty. Okay, so two hydrogen is done. We now have 4 more electrons to place. So how many electrons does oxygen have? And how many electrons total did we have to use? Done. All right, Devon. Who should go next?
Me.
You already went.
I don't care. I like to.
Devon, somebody here really wants to go. Let him go. Who? Who are you pointing to? There's a whole side of the room you're pointing at.
Where are you pointing to? Brother. Brother.
No, somebody new. Isaac. All right, Isaac. Here we go. Fluorine. How many? Well, you have 2 of them, but what's the count on fluorine? 7 times 2 is? All right, who's in the middle? F or F? Very good. And who's around it? F or F? Very good. All right, so how many electrons do we need to connect them?
14.
No, to connect them.
7.
To connect them. Right.
Let's count. You got 2 already?
Oh, we need 12.
Well, I thought you meant like how many like.
All right then,
10.
people. For the next one.
Shut up, Randy.
Have we placed all our electrons? Isaac, does everyone have 8?
Don't look at me like that.
That's easy enough. I really don't.
Okay, now that you feel that that's easy enough, let's do ones that are slightly harder.
That's not.
Sometimes you will run out of electrons and still have atoms that are not satisfied. What do you do then? You use a double or a triple bond. What is a double bond? What is a triple bond? A double bond is when 2 atoms share more than a pair. If they share 2 pairs, then we call it a double bond. If they share 3 pairs, we call it a triple bond. Double and triple bonds are special tools that you use only when you have run out of electrons and somebody is not happy. You use it only when somebody has run out of electrons and they're not happy. So it is only a weapon of last resort. You pull this card only when you have no other choice and you want to win. All right, Isaac. Who should volunteer next? No, Jackson, we're going to get new people. You don't know all the people in this class, their names?
I'll go.
Pick Randy. All right, Randy. CO2. Carbon. How many?
12.
Carbon's in the 4th column.
4th column.
4.
I thought we were looking at the bottom.
Oxygen is how many?
7.
Maybe
1,
they count
2, 3, 4,
differently
5,
in Mexico.
6.
6
Wait,
times.
I don't get it though. How come? Okay.
You don't count D. You just go
I
count
know.
over and you go 1, 2, 3, 4.
6.
Okay.
That's very funny.
How many
However,
more?
I will tell you that I have most of my life I spent here, so evidently we count more differently in the United States and Mexico.
Well, most of us here can count to 6, right? So.
Well, there must have been a problem with my teachers. 'Cause, yeah.
6 times 2 is
12.
plus 4 more.
16.
All right, 16. All right, Randy, you got 16 electrons to place. Who are you going to put in the middle? Who did I say was the ultimate monkey? No, I said carbon. Okay, put oxygens around it, and let's connect by placing how many electrons? No. You connect them by placing 2. Connect again. Now you have 4. Okay, so we have 12 more to go. That's why you said 12. 12 more to go, and you start from the outside in. Ready? 4 plus 2 is
6. 8. 10. 12. Next.
we got to go to 16.
14, 16.
All right, yay! We've placed all our electrons. 2, 4, 6, 8, 10, 12, 14, 16. Yay! Good job, Randy. Is everyone happy with 8?
Yeah.
Let's see. Oxygen, 2, 4, 6, 8. Yay! Carbon, 2, 4. Okay. Oxygen, 2, 4, 6, 8. Yay. Okay, we've got a bad situation here. Carbon is crying. I don't have 8 electrons. I mean, snot's coming out, making little snot bubbles. You know, you've seen little kids do that. That's just disgusting. So oxygen's going, no, dude, stop crying. Stop crying. What can oxygen do for carbon?
Give it some his, maybe.
Randy?
Share.
What?
Share.
Share. So this oxygen goes, okay, dude, no, stop crying. What if I was to give you 2 of my electrons and we can share those 2? So this carbon goes, okay, I feel a little bit better, but I still don't feel good. And so this carbon turns to the other oxygen and goes, will you do the same thing for me? And then the oxygen goes, no. So the carbon starts crying some more, snot bubble coming out, and oxygen goes, man, that's disgusting. That's sick. Stop that. Here. I just so I don't have to see you do that, I'm going to just let you borrow. Oh, gross. You got snot everywhere. I'm going to let you borrow 2 of mine. So now, does that really affect the oxygens, Randy? No. Does it affect the carbons?
Yes.
Turn that frown upside down. You still have tears because he's still a crybaby, but now it's tears of joy. Those are called double bonds, my friends. Double bonds. You use them only in the last resort. Remember what got us to this point. We had used up all our electrons, and somebody was not happy. Randy, who's next?
Emily.
Emily. Nitrogen, how many?
What?
How many?
1, but there's
No,
2.
it's-
2.
All right then.
Okay, there's
Talk about
2
weight.
of them. How many electrons?
Wait, 1, 2, 5,
5 times 2?
10.
Okay, so we have 10 electrons. 10. Count them. 10 electrons to play with.
I'll admit that.
Okay, nitrogen's in the 5th column. It has 5 outer shell electrons. There's 2 of them. 5 times 2. Excellent. Who's in the middle?
In.
What about the other end?
Well, they're just right.
It's on the side.
They're just like, what does that even mean?
Okay, why are you getting
Okay, let's connect them. How many electrons do we use to connect them?
2? Thing.
6.
So keep counting.
Oh, wait, am I supposed to go 4?
No.
Oh,
4.
okay, 4, 6, 8, 10.
That's it. Can't go on any further. Is the nitrogen on the left happy?
No. Well, yes.
Is the nitrogen on the right happy?
No.
It's snot bubble time.
Ew.
Okay? So, what do we do when we have snot bubbles blowing?
You share.
Now is everyone happy?
Wait.
Let's see. 2, 4, 6, 8. 2, 4, 6.
No.
It's snot bubble time.
Ugh.
So what do we do when we have a snot bubble?
We share.
Now is everyone happy?
Yes.
Mhm.
What do we call it when we have 3 bonds?
Triple bond.
Triple bond. Excellent. So that is what a triple bond is. That is a triple bond.
Wait, so is A a double bond?
Yes. B is a triple bond. C. Pick somebody for me. Not Jackson. He's already done one.
Serenity.
Serenity.
That's what I asked.
Oxygen. How many?
6,
Times?
2,
You know.
equals.
Well,
All right, who's in the middle?
O,
What about the other O?
it's on the side.
Okay. In order to connect them, we had to use 2. Let's keep counting.
4, 6, 8, 10, 12.
Is everyone happy?
No.
Who's not happy?
O on the right.
Okay, so that means it's snot bubble time. How do we solve snot bubbles?
You share the electron.
See, you got this, Serenity.
Boom!
What kind of bond is that?
A double bond.
Is everyone
James
happy?
Bond.
Yes.
Is it? Wow. Wow.
Serenity,
Yes.
give me another contestant
Besides Jackson.
besides Jackson.
This one's hard though.
Get Mr. Marino himself.
Quickly,
Jeffrey.
Jeffrey.
Right.
Jeffrey. All right, go.
Oh gosh.
One. Yes.
Glad you didn't get that one, City.
6. No. 4. Plus 5.
That's 5.
10.
Who's in the middle? Who's in the middle?
Don't make fun of us, Serge.
And beside it,
Wow.
let's connect them. Okay, be careful. What do we do with hydrogen? Leave it alone. That's it. It connects once
Hydro
and
now.
done. Once and done. All right, let's keep going. Start on the outside. 2, 4.
6. 8. 10.
Done. Done. You've run out of electrons. Okay, next step. Is everyone happy? Is hydrogen happy?
No.
Yes.
Is carbon happy?
No.
Is nitrogen happy?
Yes.
So it's, what kind of time is it?
Not.
It's snot bubble time. Who is blowing snot bubbles?
Carbon.
Carbon. So how do we solve the snot bubble problem?
Great. Double bond.
Okay, now is carbon happy? Now is carbon happy?
Yes.
Okay. You got those?
That was not as hard as I thought it was going to be.
Well, then let's turn it up a notch.
Like all the axes and stuff.
This is the last one. Here we go.
Was it just a
Why is it that SO4 had a -2 charge while PO3 had a -3 charge? Finally, after all these months of wondering, how do we decide whether it has a -2 or -3 or -1 or a +1? Finally, it's time to understand why. Jeffrey, pick another schmuck for me.
Oh,
Spencer.
You're not a schmuck.
Go, Jeff.
Bailey.
Bailey. Thank you, Bailey.
I'm kidding.
I love the faces you give each other. It's like, traitor. How could you do this to me? Bailey, sulfur. What column is it in? Try again. 6. It's right next to 3. I can understand that. And oxygen is in what column? But we have multiple ones of them, so it's 6 times. Okay, now Bailey, here's the hardest question of all. What does the -2 mean for us?
Subtract 2 from that.
You add 2, how many?
You just have to track.
You add 2 more electrons. Okay, so
You just threatened me.
whatever, and we have the threat now on YouTube. Thanks a lot. Okay, so Bailey, now you're going to find out why SO4 is -2 and not -3. Because the only way this will work is if we have 2 extra electrons. For the moment, let's ignore it and go as if it was that -2 meant nothing. 6 times 4 is plus 6 more. Okay, for the moment, this is wrong. You understand that? For the moment, let's go with 30. Let's go with 30. Who's in the middle? The one that you only have one of, and then place the others symmetrically around it. Okay, here we go. Count with me. Bailey. Uh-oh. You're so close. You almost did it. The sulfur is happy. It has 8. Every oxygen except for one of them is happy, and one of them needs how many? And that, my friends, is why it's -2. It fixes everything. We have, hey, Bailey, we have 2 more. Done. Now, this is an extraordinary situation. This is a situation where sulfate has grabbed 2 electrons from its neighbors. Sulfate is now an anion. Yesterday we learned, how do we communicate with somebody that this is an ion? How do we show it? Does anyone remember how do we show that it is an ion? By placing brackets. Okay, the brackets now tell us, Bailey, that this guy has lost or gained electrons. How do we communicate that it has actually gained 2 extra electrons? No, that means you lose 2 electrons. So you finish these up with brackets and a charge. Brackets and a charge. Good job, Bailey. Who's next? Ben. Ben, P, how many?
7.
Try again.
Oh, 3.
Try again. Okay, look back here, Ben.
I thought it was 1.
Ben, look back here. We're going right there, right? So we're 1, 2. Don't count this. 3, 4.
Oh,
5.
So see, they must be counting wrong in the U.S. too.
Oxygen, how many?
Hold on. 1, 2, 3, 4, 5, 6.
Very good. And how many of those do you have?
11. Oh, I thought we were doing 5. 3.
Okay, and what does the -3 tell us? So, 6 times 3 is? Plus 5, plus 2 more. Plus 3 more, I'm sorry, 26. So we have 26 to play with, right? Who's in the middle? Count.
Oh, 2, 4, 6.
Start on the outside, work your way in.
Hold on, I have to copy this again.
No, just do it here and then copy later.
Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26.
You done?
No.
No, this is an extraordinary situation. How do you tell people that this is extraordinary?
Put the brackets around it and then put -3.
Excellent. Good job.
We got this, Mr.
This is as hard as they get.
Oh, okay.
Well, that's pretty hard. I'll tell you that much. Well, I counted.
That wasn't so
Too much
bad.
addition.
Ben, give me another schmuck.
You're not a schmuck.
What's
I mean, you are in that sense, but not like.
That way you went to the back. We are.
No, he's already done one. Go. Kelsey, OH negative. You got the easy one. O is how many?
How do you describe what a schmuck is?
It's Yiddish, isn't it?
See hair, wear sunglasses
All right.
outside, wear
Hydrogen.
jacket when it's 95 degrees outside.
Not now, guys. Not now. And the -1 means? Total? Who's in the middle? And does it really matter? Count them. Be careful. Do I place them around hydrogen? No, folks. Some of you are going to do it, and I'm going to just sit there and laugh at you. No. Hydrogen is happy. That's it. It's done. They're afterthoughts. Work with the other one, Kelsey. Is everyone happy? How do we show that this was an extraordinary situation? Kelsey, give me the last person to help me. This is the hardest one. Carbon, go.
4 plus 6 times 3.
Wow.
Plus 2.
By the way, what if it was plus 1? What would you have done?
Like
What if this was plus 1, gang? What would you have had to have done? Yeah, subtract 1. That's right. Good. All right, so 6 times 3 is...
24.
Okay, who's in the middle?
C.
Are you guys me?
3 oxygen.
So how many electrons is that?
6, 8, 10, 12, 14, 16, 18, 20, 22,
Dear God.
24.
That's it?
Dear God.
That's it. You've used up all your electrons. Is everyone happy?
It's not.
Who's not happy?
Carbon.
It's not bubble time.
The best time of the year.
So, somebody's going to have to share with Carbon so he can stop blubbering. Which one do you want to do it? And does it matter? The answer is no. Now is Carbon happy?
C'est pas trop.
2, 4, 6, 8.
Who do we appreciate?
Yes, Carbon is happy. How do we show that this is an extraordinary situation?
Bracket.
And
Minus -2. Did I have C?
any questions?
Probably.
For homework, I want you to do on the worksheet that I'm about to pass out 1 through 3 and then 5 through 12. 1 through 3, 5 through 12.